Miss Jody coming to you here with the second video for Earth, Space, and Science. And this one is on constellations. In the last video, we talked about the asteroids, comets, and meteoroids, and then of course meteors and meteorites. And we did this little diagram here that I sent you so we could understand the differences between them. And then the second diagram on that page is this one, and it goes along with constellations. So constellations. So when we start talking about constellations, the first thing that we have to understand is what's called the celestial sphere. And so celestial sphere is celestial meaning the star bodies, and then the sphere that they would exist in, and this imaginary giant, and I'm gonna have to move my book up a little because my book is so big, it's hard to read on this side of the page. And so it is going to be the imaginary giant hollow sphere with the Earth at the center. So all that means is it's not a real sphere at all. It's a sphere that we create to help us understand how to track these stars. Because when we are on the Earth, so you see I tried to color this little Earth center here. So when we're on the Earth, we have, when we start looking up to the heavens, we start seeing all these stars. And it would be really easy if everybody just stood still. If the Earth stood still, and of course the stars are already standing still in reference to our movement. And so we would just look up and everything would be exactly where it always is. But the problem is the Earth is not still. The Earth is constantly moving. So as the Earth is moving, it's doing its rotation, which means it's going to be doing its spin. And then it's also doing its orbit. You remember that, where it's going to be going around the sun in its long orbit. And so we've got a lot of movement going on. So when we're standing here on the Earth, let's say we're at the top of the Earth, we look around, it looks as if the stars are moving. They're not really moving. We're the ones moving. And so that's real important to know. But because they look like they're moving, because we're moving, we have to keep track of them and try to make some patterns in the sky with these stars so we can kind of use it for navigation. We can understand where we're at. And then for us understanding other things in our space world, like other planets and how they're moving. And so we use these all as reference points. And so we create this invisible giant pretend sphere as if we were looking down, if we were standing on the Earth looking up, there would be this half that we would see. If we were down here on the Earth, down towards the South Pole, then we would see this part of it as we looked up. And so this celestial sphere is just this imaginary sphere that we put around the Earth to track and map our stars out. Now, this is all because of what? The rotation of the sphere. Because really the Earth's own rotation, the sphere, the one that we've created, this pretend sphere, is going to rotate around the Earth once every day. So because this is our pretend sphere we're looking at and tracking where our stars are, as we're moving, we're going to be seeing different sides of the sphere. And then also, of course, as we're orbiting too, we'll see different parts of the stars depending on the seasons too. And I'll talk about that in a minute. So when we have all this movement, we're trying to keep track of it, we talk about what's called celestial poles. Celestial poles will be the poles, that the points on the celestial sphere that are directly overhead at the Earth's poles. And so let's say, and this is not accurate to this diagram, but this is just what I drew with my little marker here. But let's say this is the Earth here, and then I put a little line through it to remember that it's tilted on its axis, right? And so when I'm standing here and I'm looking up, let's say I'm all the way at the top of the Earth where it's tilted and I'm at my, my North Pole area. If I look up and I see some stars up here, now these stars would be in here, obviously, in this pretend little sphere, but I just drew them up here so you could see them. They would be at the tops. Well, then as I am rotating and the Earth is rotating around and around, all these other stars over here and all these other stars over here, they're going to be moving. But the stars that are directly above me, if I'm at the right, at directly North Pole, geographical North Pole, then I would have, these stars would be standing still while everybody else is rotating because they're right at the top. So we're at the top of like a spinning top. You know, this one kind of stands still while the rest of it rolls around. I mean, it still stands we still have a rotation like this, but they don't move from side to side or in different parts of the sphere. And then same thing when it comes to the South Pole. If I lived down here and I was looking straight up the sky and I was looking directly at the South Pole, I'd have some stars here that would never really move because they'd be at the tops, and the rest of the stars would move around them, but we'd have those definite top and bottom points that would stay still. Now, what those celestial poles do is they give us a reference point because they're the ones that are not moving. So when you look in the stars and you see all these stars moving throughout the night and each day and through the seasons, then you can track them. But if you find those particular stars that don't move, then that will help us in reference to where we are and where the rest of the stars are. These types of stars, we call them circumpolar. They are circling the pole, meaning they're not moving across the whole rest of the sphere. They're only just right here at the tops and the bottoms. And so when the rest of the sphere is moving, well, this invisible sphere, which would be really us moving and us looking up at everything, then we would have those reference points of those ones that are always below, and they're always where they should be and never circling like the others or moving around. So with these celestial poles and these circumpolar stars, we can find a couple that can help us always know where we're at. One instance in the north area is the star Polaris. Have you heard of that before? A very famous star. And that one is going to help us have the direction of where north is, because it's going to be like this circumpolar star world, and it's going to stay there and it will help us figure out the north side. Now, when it comes to the south side, if we were down in the bottom of the Earth and the southern hemisphere, we would be using not a particular star, but using the Southern Crux, which is an asterism of a specific constellation, and that is a particular shape in the sky that you can look for, and then when you look for that, it will give you some other stars to point to get your true south. So we can use these stars, the ones that aren't moving, to kind of give us a better reference point. And all motion is relevant when it comes to, you got to have a reference point, right? So where from which area and where am I, and considering that motion. So when we see those circumpolar stars, they can really help us. Now, still going back to picturing this celestial sphere, this big invisible sphere that we've made up to track all of our stars, it's going to be broken into 88 zones. Now, these 88 zones are what we call constellations. So when we study constellations, we just usually say, oh, constellations is just pictures that we've made out of the stars. But really, it's zones. It's zones of stars, so that it will help us understand where all these different stars are and track them and create this beautiful celestial sphere that has them all mapped out. Now, these constellations, 47 of them were named by ancient people, and they also used a lot of, or created and used a lot of the mythology of the time to create stories that went along with them. Now, back in the day, the ancient people, they had more time for laying around looking up at the stars than what we do. Well, I guess I shouldn't say more time. They were less distracted than we are. And so they spent a lot of time tracking these stars. And the 47 are named by these ancient people. And then also, not only just taking more time to map the stars, they had less light pollution. So light pollution is when we have too much light going on from our cities and our street lights and all that it blocks out the beauty of those brilliant stars, because they're the most bright and brilliant when you're in just complete darkness. And so if you ever have a chance to go camping where you're at somewhere that's really isolated, you get a different understanding of the stars when that happens. And it's got to be something real isolated. And I had this experience when I was, I had a survival camp some years back for some of my junior high and high school students at a different program that I used to run. And we did a survival camp type week where the kids had to learn survival skills, and they had different challenges and stuff. And we slept out in tents and such. And we had a base camp, and it was a great experience. But one of the best things was seeing the kids see the stars for the first time in their lives. And I remember the first night or two they were sleeping in their tents, and then by the time night 3 at the latest, they were sleeping out on their cots and underneath the stars, and that was fascinating. And you could hear the sounds of all the animals, but the stars were the most fascinating. That was something that really captivated them. They had never seen anything like that because it was in the Pennsylvania wilds, and it was in an area where you couldn't even get like a grocery store for an hour away. It was a very remote area along a river. Beautiful place. So I've experienced that, but some people haven't even experienced that. But imagine those ancient people back in the day being able to see the beauty of those stars. And then 41 of them are named by modern astronomers. And the modern astronomers have put together the remaining of the zones. So 88 zones, constellations. Now, with constellations, we sometimes get mixed up with asterisms. And asterism is a group of stars that are used to form a picture or represent an object. And we are used to this, like the Big Dipper, the Little Dipper, all of those things, Orion's Belt and stuff. But we have to remember that the pictures sometimes are not the full constellation. Like, say, for instance, the Big Dipper, it's actually in the constellation of Ursa Major. So the constellation, one of the 88 zones, has the Big Dipper in it, which is an asterism. And so we got lots of cool asterisms to help us try to keep track of these as we map them out in this pretend celestial sphere here and figure out where everything is. So with that, we look at constellations and say, okay, there's some issues with visibility when we're tracking our stars. Obviously, we could have visibility problems just with our local weather. But if we take that out of the way, let's think of some things that will cause some problems with seeing the constellations. One is latitude. So that means if we picture this, now this is the invisible or the pretend sphere, but even on the Earth, you would have latitude lines that will help you. Now, the latitude lines are what's the ones going across here. And then, so if you're way up here, you might be able to see this way better. What if you get on the equator? If you get on the equator, it's going to be really hard for you to see any of these stars that don't move at the tops and the bottoms to help you get a reference point. So you won't be able to see that, and you're going to see a different area of the sky, right? And so we have that latitude problem depending on where you are. And then you also have the hemisphere situation, because if you are at the top at the southern hemisphere, northern hemisphere, you're going to see this little part of the half of the circle. Oops, let me move that over, half of the circle. And if you're down here, you're going to see on the southern hemisphere, you're going to see this half of the circle for the majority there. And so your hemisphere can change your visibility of these constellations. And then, of course, the seasons. Now, the seasons, as they're moving through, we have to remember that the Earth is going to be on that tilt. And, of course, this isn't a picture of the Earth, but there's my little Earth there. So he's on a little tilt, and so as he's going around the sun, that depending on which direction that tilt is going to create those seasons for us. And so some of these constellations are going to be seen better. Doesn't mean they can't be seen in other seasons, but seen best in these particular seasons. And so they categorize them as spring constellations and summer constellations and autumn constellations and winter constellations. Now in our book, that gives lots of good details about each one of these constellations, but I didn't want us to have to spend too much time with our notes on this. So what I did is I just listed some. And then what I thought would be good is if we just did a art craft that's a visual of one of these constellations, or even an asterism in one of those constellations. All right, so the constellations, the spring ones that you can see the best in the spring: Ursa Major, Ursa Minor. You heard of that, Leo, and that reminds me of little Leo in our class. Hope you're doing well, Leo. Booties, Virgo, and so these are some of the spring ones. Some of the summer: Draco, Lyra, Cygnus, Scorpius, and Sagittarius. You've heard that one before, I'm sure. Some of the autumn ones, I always say this wrong, Cassiopeia, I forget how that's, Cassiopeia, something like that. I forget, that's a really weird one, but once I hear it, it will be like, yep, that's how you say it. Cephas and Pegasus. Winter constellation, Perseus, Orion, Canis Major, Gemini, Taurus. And so we have these different ones that we can study. And in our book, it gives us writings about all of them. So read that. It's good material and get to know your constellations. And of course, if you have a cell phone, you can get an app that you can use to point to the sky. And it's like Sky View. There's a whole bunch of different ones, and it will show you in the sky where some of these major constellations are, and you can get to know your stars that way also. Now, with that, I thought it would be good to do a little art project, because though I want to do some of our work when we get back together, if this drags on too long, I don't know how much time we'll have when we get back together. So I thought if we would do a few little ones, art ones that we could just do at home, that would be easy, and we'd have supplies at home for it. So this one I thought would be easy to do with our constellations. And so what I did is I just took a piece of paper or a piece of cardstock, and then I just drew out a constellation, or you can do a constellation or an asterism. And this is just of the Little Dipper. You can barely see it, but see I put some little points just so I could remember where they were going to be. And then I'm taking just my white crayon, and we're going to just create a wax resistance. Now, a wax resistance artwork is, if any of you have been in any of my art classes, or we've done this actually a lot in just our regular science stuff too, is when we use wax and we really push it onto the paper, and you can't see it because it's a white crayon, but you push it down real good without breaking your crayon, of course, and that way the wax is sticking to the paper real good, because then we're going to use a substance to cover it that's going to use a lot of water. And what happens is water, the wax that's on the paper, will resist the water. That's why it's called a wax resistance. And so it'll resist it, because in chemistry we know that certain molecules don't work well together, and water and oil-based type or waxy type things don't really work together. So this wax will be good because it'll stay right on the page there, and then the water, the colors, the marker and the water that I use is going to go across the rest of the background. So I made sure I pushed it down real good and got my good wax on there. And then this top one, since this top one's Polaris, I want to make it shining brighter, so I'm kind of making it a little bit bigger, kind of making it little rays coming out, asterisk-like. And then to make it easier, if you have watercolors, you could use black watercolors or blue or whatever. If you don't have any of that, and just to make it easy, because I figured most people have crayons, and then I figured that most people will have markers, that you could just use a marker to color over it and then add some drops of water. Now, my markers are terrible, and actually that one's really, really bad, but I had found another one that wasn't too bad. You know my rule with markers, eventually just throw them in the trash when they don't work anymore. And these really they've seen their day for sure. And so just taking the marker and just scribbling all over it, and it won't look very nice yet because obviously I'm just scribbling it, but once I add the water, then the colors from the marker can bleed. And then my wax can pop off, and I can see a little better of it here. And so I'm going to do this, get this looking all good real quick here. And I did this project a minute ago, well actually a couple hours ago. I already recorded this video, and then my phone messed up and would not do it correctly, so I had to redo it. So I have another version of this too, where I actually added the lines and not just the white dots the first time I did the video. So I'll show you that one too. But see how I've just scribbled all over. And then I have a spray bottle, but you don't need a spray bottle. You can just put a little water on your hands like this and just dribble it down. And then that way, as we're putting the water on there, which I'll do this just to make it quickly, or to make it kind of quick, then the water is going to be moving around. You see how my white is already starting to pop off, my little stars pop off the page there. It's because the wax is resisting it. Where's my other star there? He's not very good there, being resisted. All right, but over time, then once it dries, then my colors are nice and beautiful here, and I could rub off some of it if I didn't want too much. But eventually, you see how the wax is resisting the water and the colors there? And you could even use acrylic paint if you watered it down, or if, like I said, if you had watercolors. And then in the end, when it would dry, then you'd have your little constellation. I'm trying to remember which direction was where's my good Polaris here, because this one, I might not have put as much color on this. Oh, I think that's Polaris up there because it's looking a little brighter. I'll show you what mine looked like the first one, and you might want to do it this way too because it definitely pops out. But I did the white crayon first, and then I drew the lines in yellow to signify where they would be tying together. And then I did my marker and I sprayed it, and see how pretty that turned out. And this is something you can save, and then I can put in your journal, and this would be something of our own creation, so we can keep trying to be a little creative during this time that we're not able to do all of our fun labs and those sorts of things. So now that I look at this, and I'm going to have to see the dried version of this one, but I really like the one with the yellow lines because it really outlines it. It's hard to see where my stars are with creating my little dipper there. Okay, so you can do something fun like that, and with any of the constellations that I showed you or that we talked about and we wrote on the diagram. Okay, all right, so I hope you're doing well. I'm also going to be sending you a video on using the constellations and the stars for navigation, and it's really cool because it shows you how they did it and how they do it, if they still need to do that from time to time. And it just gives you an understanding of how valuable these patterns in the sky that we've created in this invisible pretend celestial sphere.